getting a lot of questions about this rod. And all right, the Canadian guy, he put a video out there and everyone's going crazy over it. It's driving me crazy to get all these comments and on the side. And frankly, I don't post them because he's wrong. And I actually delete them so we don't get down that same hysteria. I want you to take note of a couple of things here. No offense to you guys that watch it, that are going down that line with that. No offense to you at all. We have a human here, so this human, we're going to say he's what, I don't know, 3 foot wide from elbow to elbow. If we could move him over to scale, or this one here, we're looking at the tooling here in blue. And this, I believe, would be what they refer to as, sometimes referred to as a trumpet. This is the part that was inserted somewhere into this guy here. Now, this distance from here to here is approximately 3 feet. I've looked at many videos and moving of the bridge, etc. I did see a void here at one dark video in a flyover, but nowhere did I ever see approximately 3 foot of post-tension bar sticking out. And you need that to be able to stick this tool in that far, or at least be able to grab it. And with this, you need this much from here to here at minimum to grab it and start jacking it. All right, so here we go, and plus a little bit of cap there, tooling. So this appears to have already been sticking out at this distance when they went to work on the bridge, which is a major issue for me right there. What's with all the extra post-tensioning bars sticking out? I don't recall seeing it in any videos previously. Now, jumping on, let me just jump over to comments here, and I'm going to read what I'm going to post to this person here. Before I do that, though, this is on the Florida Department of Transportation post-tensioning. This is one of my things I keep mentioning to everybody is you must grout under 462.7.7.2.4 tendons. Do not exceed 14 calendar days between first installation of pre-stressing steel within duct and completion of the stressing and grouting operation. For post-tension bars located in superstructure in all strands regardless of location. So grouting is so important, and I know you guys think it's insignificant. That bonds the post-tension members to the bridge, in this case the bridge, the concrete around it. Without that, you have voids, and it can move up and down. It can cause a fissure. I would like to say a fissure, if I can use that word. That void is just a point where it's no longer a solid piece of concrete. Of course, it can break in that void, and this is what I'm saying the load path is. I'll put this link to this here, and you guys can troll it all you want and get real, you troll it, have fun with it. But you see here are the tolerances, plus or minus a ¼ inch, etc. Now, going back to the bridge to finish off my comments here, it's a diagonal. So you guys are assuming the engineer is stupid. And no offense, the engineer has to be present when they're post-tensioning. They just don't allow that to Joe crew member to just say, you do a good job, we wish you best. Now, they'll be there to take numbers down. Now, so we got the crane there. The crane was there to lift that tooling. That tooling is hundreds of pounds. So you're not going to, I guess you could, a couple of strong guys could lift it. It's not some lightweight tool. So the crane was there to help hoist that up. I'm sure of that, as I've seen on many job sites. Now, moving on, the engineer would have been present as you can see the diagonal in your mind here. Let's see if we can just come to the diagonal. I'm going to read this to you. So this guy, David, I'm writing him. The engineer is present during post-tensioning, and the post-tension bar samples are required to be tested before installation. So this will be in here showing you your testing that's required, the records that must be kept, etc. These bars had a known failure point. So during the testing, they'll figure out where it's going to yield, where it's going to then, and also where it will fail. So you guys are implying, no offense to any of you, and I guess I'm being aggressive, but go with me here. You're implying that the engineer is so stupid he just said, and the workers are, just keep cranking it up. Don't read this yet, please. Bear with me. So you're implying that he just said, keep cranking it up, do more, I need more, I need more, I need more. No, there are knowns here. So the post-tension bar, you know that, let's call it 200 kips it can take. And say it fails at 200 kips, okay. So it's a I'm sorry, let's do a different number here. It say it requires 200 kips. The bar can do 200 kips in service. That's the max it can do. So at one point when you post, and the column can say the column can take 400 kips. Well, if you can apply your 200 kips, you now maxed out your post tension bar. So it's done. You're not going to now say, hey, crank it up more, because as an engineer, you would know you're just causing the bar to fail and you're not doing anything. You're not doing work at this time. It's going to fail. So you don't do it. So this is about the buckling. Everyone is saying that the post tensioning caused the buckling. Well, to buckle, you would have a known number on that member. Let's just go here. So you've got a known number on that diagonal. Let's see if I can find one down below. There's B-roll. All right, I was trying to find that. So let's go back to it's a B-roll. So this diagonal has a known failure rate also in this direction and in that direction. In this case, it's implied. Here's the thickness, the width is greater than the back end, vice versa. It doesn't matter. The engineer would have known that the angle, the flatter you are with this, the more it's now going to have a failure at the center, and it's going to be a tension here. But nevertheless, as you stand it up, it's totally in compression, as you can see at that point, and you can visualize buckling easily. As it's lying flat, buckling is really not an issue at this point. It's more going to fail under tension. When you split the difference, let's call it, now it's on a diagonal, as we know the diagonal is how it was installed. It's now going to be under part tension, and yes, it will still have some buckling failures. So let's talk real quickly. For clarity, tension is created in this diagonal number 11. As it's not vertical, it has a horizontal lean to it, a pitch. And tension is created at the bottom of this. This is why you would add a post-tension rod in the bottom half of this to counteract the forces of the tension that's created, as this is in a horizontal plane. And the more it's on a horizontal, the more it has tension issues. At the bottom half is where you think of tension in this case. On an overhang, you think of tension at the top because of the overhang. But back to this one, your number 11, your tension's at the bottom here. This is why you would have post-tension cables, post-tension rod installed. To test for buckling, first you check when you're checking members, first you check for compression to see if it can take the loads. And then you check another formula you run is then a buckling formula. If it doesn't pass the buckling formula, the buckling formula is your limit. You're done. So your guys, or a lot of people are implying that the engineer is so stupid that he didn't know that what the column's buckling rate failure would be. Of course, the engineer would have known that the column will buckle at, say, 300 kips. He doesn't have to worry about it because he's never going to get to 300 kips because the post-tension bar is maxing out at, say, 180 kips. So he's never going to get near buckling this member even at that diagonal, that shape. So it's not even a factor unless now we have failures. Unless you have a failure, the engineer never post-tightens past the member's limits, whether it's the post-tension bar or the buckling of any member. It's not going to even happen. Even if he wanted to crank it up, you just don't do it. So obviously stressing a post-tension cables or bars to their limits is begging for failure. So you would not do it. You would not put this under. You just wouldn't do it. It just, it doesn't make sense to me. I get you guys watched that guy from Canada and he showed because I got so many links to look at it. So, or told to look at it. Yes, he ran it to failure, and then he says this ejected at that point, and that's how this came there, and that's the smoking gun. His word, smoking gun. It would have never been loaded to the point of failure. Moving on, take note, this school is an engineering school, and I'm going to mention that again in a moment. But I just wanted to share some of the images here. You could pause them and reread them, showing how they're bragging about their skill set. They're also the inspector for this job site, literally. This school is an engineering school, and as I understand it, per their contract, there will be no post-tensioning going on unless the representative from the school is present. Obviously, you wouldn't have a post-tension member from a structural school, if you will, structural engineering school. You would not have a non-structural engineering knowledgeable post-tension person as your representative during post-tensioning. Now, the engineer taking numbers from these while this was going on, while the post-tensioning was going on. Would have been practical for them to be on the bridge while this is happening? Yes, and it's usually a direct feedback. Usually you'll see chairs set up and the engineers waiting for some time while they're doing a setup and monitoring. We got 2 workers on the bridge, so it does kind of put us separate from where the engineers could be located if 2 workers are there. But with that said, maybe they were in this man lift. Maybe the engineers were in there, or at least one engineer, let's call it. Again, I'm going to link this, and hopefully this will help you determine that number 11 did not buckle by post-tensioning. I believe the failure was, it did buckle as a result of post-tensioning, not to be double-talking you. So they were post-tensioning, and during that, another failure happened, or a result, as you see in many of my videos, we have multiple post-tension longitudinal cables that I think are in the wrong position per their own drawings. With that said, maybe even the engineers, there's so many things, all my videos, I'm not going to rehash all of that. But the load path, so this was cranked up as it was being post-tension. I think the deck failed. Once the deck failed, yes, the load transferred onto number 11 and number 10. Number 11 being the longer diagonal, the steeper angle, showed buckling, and number 10 just drove the forces right through the deck, right through the deck down to the lower deck, and there was no stopping it. So yes, you saw the buckling as I believe the canopy was failing first. I hope this was loud enough for you guys. You all complain about my volume, and and I know it may sound aggressive. I really appreciate all you guys. I'm just resolving that I get so many of these private messages